Hi, I'm Farzad Tauhidi. I'm a senior manager of product management on the Autodesk Platform Services. And today we'll be talking about the case study on a large AEC firm in the European region, Arcadis, who leveraged Autodesk Assistant and the AEC Data Model APIs to transform their project workflows. But first, we'll start with this exciting safe harbor statement, which is a reminder that any purchasing decisions should not be solely based on the contents or forward statements made during this presentation. And a little slide on the team that made this possible. Claudia and Mayank will present themselves later on, but there's also an honorable mention for Joshua and Saurabh, who played a pivotal role in this presentation. So on the agenda today, we'll start first the session by giving a quick overview of the AEC data model and the Autodesk Assistant, which are respectively the data repository and a natural language interface to this data repository. Next, we'll give a walkthrough of the capabilities of the Autodesk Assistant that were used during this case study. We'll then look at the case study itself, where Arcadis, a large AEC firm based out of the Netherlands, which embedded the Autodesk Assistant within their custom application to increase productivity of their engineers by enabling them to query into their Revit models using natural language. We'll then wrap things up with some key takeaways and next steps. So let's begin with a quick overview of the AEC data model and the Autodesk Assistant. So the fundamental idea of a data model is to decompose different aspects of CAD file as granular data and manage them in a hosted cloud database. This decomposition allows users to tap into only bits of data that they need instead of moving files around, and can make sure that users can trust the data they're working with. And because every change for every granular bit is version, you are always working with the right data instead of managing the files around. And so by making data more granular, accessible, and transparent, we can start transforming manual workflows into automated workflows. An analogy we like to use when comparing a world where files are more dominant, to one which data is more granular, is that of a road atlas and Google Maps. So with a road atlas, finding destinations or route planning is a very tedious and manual process. Much like how today's design and make industries rely on data that's trapped within files, that only the authoring CAD application can access to be able to fulfill their workflows. In this world, which is the current world that we live today, the current situation, desktop plugins are built, maintained, and manually ran to access data. BIM quality control is also done very manually by opening and verifying each Revit design. Synchronizing bill of materials of parts to inventory management systems like SAP is done also manually by opening each and every Fusion or Inventor designs. And interoperability is largely driven by file exports and imports, uh, which need a lot of post-processing, versioning, and storing that data. So moving from files to granular data is like moving from a road atlas, a paper map, to Google Maps. And just like how Google Maps revolutionized how we move around the world, which made it easier to plan our routes, find detailed information about destinations, see live traffic. The Autodesk data models also opens door um, to building web experiences that can access up-to-date data without the need of manually extracting that same data through desktop plugins. Its APIs provide granular access so that you can automate BIM quality control, like validating family name convention. It also allows you to automate your synchronization of CAD data with your ERP data and also have more connected workflows. To put the data models in perspective with the overall Autodesk platform vision, it helps unlock valuable design and make data to make it granular that is generated by our flagship products to begin with, and provide access to this granular information via APIs. This then allows Autodesk to build high-value experiences through the industry cloud's Forma Fusion flow. And lastly, but not the least, we hope to enable value differentiating outcomes that will fuel digital transformation and disrupt the industry. Here's an example that showcases how this granular data is accessed through GraphQL APIs. What is shown here is a query explorer. It's essentially a developer tool that allows you to play around with our APIs, test them, and iterate on them. And as you can see, the data models provide filtering capabilities that allow you to get the data that you need. For instance, in this case, we are filtering the entire design to build a furniture schedule. And that's done simply by searching on the furniture category and declaring the relevant property names to be returned. All right. Now, what you saw so far was a more technical way of accessing data. For that, you still need expertise in software development to get a meaningful outcome. But with the advent of large language models, which has gone mainstream due to applications like ChatGPT or DeepSeek, we are looking at different ways to make it easier to interface with the data through natural language. And this is where we built a fine-tuned LLM on the Autodesk data model to be able to quickly generate complex GraphQL queries, like being able to query for elements on a level, as you can see in this video. By doing so, it helps speed up development and reduce the time spent reading documentation, writing queries, and testing them, which can take up to hours to be able to just get to a first draft. But now with Autodesk Assistant, you can get to this first draft in just a few seconds. And this LLM will be available through the Autodesk Assistant experience. And Autodesk Assistant is beyond just LLMs or a query into the model. It is very much context aware. It's essentially an AI-powered assistant for your design to make experiences. And the goal for this assistant is to be able to embed inside Autodesk products and act as an interface to Autodesk capabilities, whether it is to accelerate the design process inside Revit, or ask sales or support related questions, or be able to gather insights and recommendations. It will all be powered by the Autodesk Assistant experience. Here's an example of an end user experience that leverages the Autodesk Assistant capabilities to power an advanced search use case. This is an internal proof of concept that was built in the model coordination ACC module that augments the viewer capability with semantic search features and helps alleviate some of the pains of manually filtering and using buttons to be able to filter. And here is another use case where a PEC, which is a large American engineering consultant firm, built a proof of concept during the alpha program of the Autodesk Assistant. And in this POC, PEC leveraged the Autodesk Assistant to add a chat functionality embedded within their custom application. By doing so, they can boost their engineers' productivity by streamlining the process of calculating energy loads per room and picking the right HVAC system based on the energy demands and additional information that they can query through the Autodesk Assistant using natural language. Like in this example, after calculating the energy requirements per room, an engineer can then get the roof slope information by querying the model through the Autodesk Assistant, and then filtering the HVAC system that can be best installed on a particular location of the roof of the building. So now that you got a sense of what Autodesk Assistant is, I'll pass the baton to Mayank, who will walk you through some of the capabilities that we are working on, as well as a demo app that showcases them all.
Thank you, Fazad, for giving the overview. Hello, everyone. I am Mayank Singh, senior data scientist working in PSET PB data science team, and the lead data scientist on Autodesk Assistant DMD plugin. Let's take a look at the capabilities of the Autodesk Assistant DMD plugin. Currently, the DMD plugin supports 5 core functionalities that deliver the significant business value. The first functionality is the ability to retrieve individual instances of element of a particular category from your Revit design. For example, you can execute queries such as show me all the doors or a more complex one like show me all the doors, walls, and furniture. The DMD plugin is not limited to the category-based queries. It supports advanced filtering, enabling you to perform multiple matching criteria queries like show me all doors with height greater than 1 meter and width smaller than 0.5 meter. Another feature that enhances the interaction with the DMD plugin is the ability to discover categories and properties within the Revit design without opening the 3D model in the authoring tool. This functionality is integrated into the demo app, providing autocomplete suggestions as you formulate your queries. Additionally, the DMD plugin allows you to query across design within a project or even within a hub. For example, you can ask questions like, list me all the doors in this project, and it will query all the design within the project to get the results. Now, building trust and maintaining transparency are the key consideration in our project. Therefore, we have incorporated AI explainability, which generates a detailed, step-by-step approach on how the results were produced. Now, let's take a look into the core module that enable these capabilities. The DMD plugin has 4 different core modules: metadata extractor, recommendation engine, interaction engine, and data fetcher. Let's start with the metadata extractor. Now, with metadata extractor, you get fast access to the high-level model parameters such as categories, properties, and level values that are used within the Revit design. It also ensures that the DMD plugin has access to the most recent metadata to answer your queries accurately. This metadata also helps in generating recommendations tailored for each design. There are 2 submodules to support this: retrieve metadata and update metadata. Let's take a deeper look into the retrieve metadata submodule. It takes scope and scope ID as input, where a scope can be a design, project, or hub, and scope ID is a respective identifier. As for the output, it returns a list of categories, properties, and level attribute values that are used within a given design, project, or hub. Now, this information is fetched from a cache database for faster retrieval. Moving to update metadata submodule, it updates the cache database from which the retrieve metadata submodule retrieves the values faster. It fetches the metadata from your Revit design using the AEC data model GraphQL. It takes the similar input as scope and scope ID, but additionally support 2 parameters. That is, force update, which allows forcefully pulling the metadata from the AEC data model and skipping the cooldown period for retrieval. And store custom parameters, which allows caching the custom parameters as well. By default, it is set to false, meaning that it only caches the Revit built-in metadata attributes. Now, this fetch metadata is stored in a database for the cache purpose. Now, let's move to recommendation engine module. Now, there is one submodule in this, that is generate recommendation. It generates tailored recommendation for each scope, which can be design, project, or hub. And it uses the metadata cache for each scope to generate a category-based recommendation on demand. These recommendations are useful for getting started with the interaction with your Revit design. Now, diving further into the functionality of generate recommendation submodule, it takes input as scope and scope ID and an optional parameter of nums recommendation that limits the number of recommendations that are generated. For the output, it generates a list of recommendations where each recommendation has a prompt that is a natural language text describing the recommendation, like show me all the doors, followed by acknowledgement prompt that is an acknowledgement response for the prompt, query that is a GraphQL query based on the recommendation, filters that a canonical representation in JSON format of the data constraints that are applied in the GraphQL query to get the requested data from the AEC data model. And lastly, the explanation, that is the detailed explanation of the generated response. Now, one of the most important module is the interaction engine, which basically works in conjunction with all the other modules. This module provides the capability of interaction with the Revit design in natural language. It processes the user query and generates recommendation based on that. The generated recommendation has the same format as the output from the recommendation engine. Additionally, it generates future recommendation based on the similar categories as mentioned in the user query. It also supports querying the owner information for the Revit design. It has one submodule, that is question and answer, as it supports the interaction in that way. The QA submodule takes an additional parameter, that is user prompt, to capture the user query in natural language apart from the scope and scope ID. As for the output, it provides a high-level textual response followed by a list of recommendation and future recommendation. The structure of the recommendation object is consistent here, consisting of prompt, acknowledgement prompt, queries, filters, and explanation. Now, the last core module is the data fetcher submodule. Let's look into that. Within this, we have a GraphQL data fetcher submodule, which basically calls the AEC data model GraphQL to fetch the data. It returns the output in the same format as the AEC data model GraphQL, but it is scoped to only allow the GraphQL queries generated by the DMD plugin. This submodule allows fetching the data using the GraphQL queries generated by the interaction and the recommendation engine. It takes input as a query, which is the GraphQL query, followed by the variable, which are the respective GraphQL query variable, and filter, which are JSON object having the canonical representation of the data constraint. All of this is gathered from the output of the interaction and the recommendation engine. The output of this submodule is the requested design data with the user constraint from the AEC data model. Now that we have explored the core module that powers the DMD plugin, let's summarize them and see how we can use them to create a workflow for seamless interaction. First, it initializes the context by fetching the most up-to-date metadata using the update metadata followed by the retrieve metadata submodule. Now that it has updated the metadata for the context, it generates recommendations using the generate recommendation submodule. This provides the sample recommendation to choose from for the selected design. Then, to enable interaction with the Revit design using the custom prompt natural language, it leverages the question and answer submodule. And finally, it fetches the requested data from the AEC data model using the GraphQL data fetcher submodule. The fetch data can be visualized using the 3D viewer for more intuitive interaction. Next, we have a short demo recording of the DMD plugin demo app from Saurabh, showcasing the workflow of these core modules. Okay. Do I need to do some setting for that?
Yes, 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 there is. Okay, so okay, so sounds good.
Now, let's take a look at a case study from one of our customer, Arcadis, on how Autodesk Assistant DMD plugin boosts the productivity of their workflow. Over to you, Claudia.
Thank you, Mayank. I am Claudia Lavri. I'm a full stack developer at Arcadis on the OTL team. And I'm going to present to you the case study that we did in our company on the Autodesk Assistant. First, a really short introduction about us. Arcadis is a global company of now over 39,000 people. And you may know us for the consultancy and engineering services, but we also offer program and cost management services. But to get to the matter in hand, which is the Autodesk Assistant, I'm going to present this case study to you in three parts. First one being the problem which the assistant has solved for us. So first and foremost, I want to mention that the Autodesk Assistant has been integrated within the OTL project. And in order to explain this in a better way, I'm going to present what OTL is. OTL stands for Object Type Library, and in Arcadis, we have developed this in order to standardize our data. You could think of this a bit like a recipe, where the recipe itself is an asset, the types are the ingredients, and the amounts are the information requirements. And we have developed this not only for the cross-project insights, but also for the cost and sustainability analytics. But here we're not talking about recipes, we're talking about bridges and roads. We're not talking about ingredients, we're talking about approaches and abutments, and not about amounts, but of spans, lengths, and widths. Here you can see one part of our project, which is the OTL viewer. It's a solution that acts as a dictionary to all the standardized data that we have done. And besides this one, we also have the OTL optimizer, which you're gonna see now. And this solution was developed in order to use all that standardized data, but project specific. Now, remember this one because you're gonna see it again in a couple of slides. So this OTL project provides, and the OTL standardization provides an ideal environment for the high performance AI agents. So what was the problem before? Well, it was a bit challenging to work with the 3D model data in an efficient way. And more specifically, the manual labor that was needed in order to extract, search, and interact with the geometry information. But that problem is solved now because we have used the Autodesk Assistant, which actually brings us to the second part of this use case, which is the solution. And for this, I'm going to present a demo of the Autodesk Assistant within the OTL Optimizer. Here we can see a model that was loaded within the APS viewer and a separate tab for the Autodesk Assistant. Now we need some geometries from the model, so we asked the assistant to get it for us. And in this example, we wanted to retrieve all the windows. We can see it already retrieved over 400 instances. And because we also want to leverage other functionalities which we have previously developed within the optimizer, we have asked it to add those geometries as instances within the project structure, which you can see in the left side, and to extract the information from the geometry in the attributes panel, which you see in the middle side. Now, as you can see, it already started scanning the model, getting all the windows. The geometry is ready. It added them by level under facades. And we can see those facades being created in the structure. And after all those instances were added in the structure, we can see that also the information that was within the model was directly extracted to the project structure within the attributes of each instance. So pretty exciting stuff from my point of view. And if you're curious what's behind this integration, I have prepared an architecture for it. Just to explain this in an easy way, the orange box, which you see in the middle, is a reflection of just a couple of its functionalities, of the optimizer functionalities. And I'm going to explain this architecture on the use case which I've just presented earlier. So first and foremost, I needed to add a model in an ACC hub within the ACC storage. That model is what you've seen earlier, which is actually the Arcadis building in Amersfoort. After that model was loaded, it could be shown in the viewer, which is hosted within the optimizer. Now, after that model was loaded in the ACC storage, the AEC Data Models service already started preparing and processing data in the back. We need all that data in order to interact with the assistant. When the user asked for all the windows, like in the example before, he or she interacted with the chatbot interface. The interface exchanges data between both the Autodesk Assistant and the AEC Data Model API. Now, we asked it to retrieve all the windows. The assistant checked if it understood correctly. We confirmed that, and it gave us all the information about the geometries that we needed. But we also needed some model-specific information. That's why we made some queries with the Data Model API. After all that information was then retrieved, we could show the geometries within the APS viewer. And because those geometries were selected, we could then leverage the other functionalities which were mentioned, adding the geometries as instances to the project structure or project decomposition, and extracting the details in the attributes and materials panel. Now, I also have some tips when integrating this. So if you want to integrate the assistant in your solutions, you may find this interesting. I interacted with with two queries that I think were really important in the development. First one would be the element group extraction status. And why do you need this? Well, when you first upload a model within an ACC hub, the AEC Data Model service starts processing the model in the back. And you need all that data to be extracted successfully in order to make use of it with the Autodesk Assistant. You can check if the extraction was done with this type of query. And the other type of query is the element groups by project. And this was useful when extracting the design information, which I've just mentioned earlier, because I also needed specifically the ID of the model itself. but you can also find other information in there. Now, to get to the actual benefits, here we have a side-by-side comparison. The big window shows the workflow with the Autodesk Assistant. It is the same use case which you've just seen earlier. Here we ask for the geometries directly and to add the geometries as instances and then extracting all those values. In the smaller window, we have the usual workflow, which we would have used before. And that requires a lot of other manual steps. So selecting all those geometries by level within the APS viewer, adding them under facades, all that also being repeated because you want to add them by level. And after that, making use of other functionalities in order to extract the instances. So a lot of other steps which we can skip now. And we can see that the assistant is much faster. We can take a look at the timestamps. It will be almost over. I also want to note that with the Autodesk Assistant, the user doesn't need to be either an expert on the APS viewer or the optimizer itself in order to achieve the same result. So both workflows stopped running. We can see that the workflow with the assistant took just 2.5 minutes, while the usual workflow took almost 13 minutes. So that means that the assistant is 5 times faster at doing the same job. And because we like to see some metrics, with the comparison that you've just seen and others that we've done in the background, we have concluded that we have 95 less incorrect data. We can save up to 190 hours for a project in a year. And as you've seen in the timestamps, it is 5 times more efficient. And that is just the implementation for now. We also prepared some next steps. So we are now in May 2025. The assistant is already saving us a lot of time and implicitly a lot of cost in the OTL project. In June this year, we want to integrate other AI agents. And so by August, we want those AI agents to write back data to the model cloud-based. And then in September 2025, or maybe October, we would like to have a fully AI automated and cloud-based client delivery. So pretty exciting stuff coming up this year. But that's just from my side. I will hand over then to Farsad to present you the key takeaways.
All right. Thank you, Claudia. Thank you, Mayank. Some great stuff were presented today. Just want to wrap things up with a summary of the key takeaways from this presentation. First and foremost, we got to look at the Autodesk Data Model and the Autodesk Assistant. The way you can think of it as is Autodesk Data Model is essentially where the data lives, is that data repository, and Autodesk Assistant provides a natural language interface to that data repository, whereas in a traditional sense, you would have to use the APIs to be able to get access to that data model. So it essentially provides a lot more simpler way to access the data and empowers non-designer personas to also work with the data. Second, so what you've seen here was essentially a glimpse of the Autodesk Assistant plugin ecosystem that enables agentic workflows that could essentially be leveraged to increase your productivity through either native Autodesk experiences or third-party experiences like Arcadis has shown and PEC as well. And finally, Autodesk Assistant is essentially expanding its functionality. What you saw so far was a part of Autodesk Assistant, which allows you to access Autodesk Data Model, but you can think of the Assistant being embedded in our design tools that allows you to work with native operations within Revit, Fusion, and others. You can even use it within our sales, Autodesk.com, where you might have questions on the products that you're about to purchase, or membership questions. So all of this will be powered by the same experience, and the functionality would expand. And what Arcadis showed today was an art of the possible scenario. Once Autodesk Assistant becomes more available and can be integrated into your own custom experience. So as a next step, we have this QR code that we prepared, and this brings you to a form that where you can enter your name, the company you work for, your email, and we will reach out to you for future beta testing opportunities, have more discussions, feedback on the roadmap, and validate our strategy with customer input. And with that, I'd like to thank all the viewers tuning in, and if you have any questions, please do fill out this form, and we will reach out to you.